welcome you again. Today we are going to solve another type of differential equation, another type of differential equations. In the previous video we talked about the variable separable method. That was really easy. Today we are going to talk about first order homogeneous differential equation, how to solve first order differential equations. If there is noise, please ignore them. There was some kind of festival going there even today as well. So in the meaning of homogeneous is appearing homogeneous homogeneous appears kind of different places in the domain of differential equations. Actually, in different places the meaning different types. In first order homogeneous, now here we are going to about first order order first order homogeneous. Also there is another thing called linear homogeneous and non-homogeneous. These two are not the same and they are mainly two things. What does this mean in first order homogeneous? Means before that, how we can identify if this equation is a homogeneous equation. Let's say we given dy by dx. Remember we are talking about first order equation, so only dy by dx is 1 is the highest derivative. So only dy by dx is what we can get is equal to fxy. If this fxy is equal to f lambda x lambda y, we call it homogeneous. So this is the condition we should find to satisfy, to identify to homogeneous equation. If this is satisfied, this is a homogeneous equation. What does this mean is that even we scale x and y, it doesn't matter. It doesn't matter the fxy. So it is same as fxy. As an example, if we have dy by fxy is dy by dx is equal fxy is equal x plus y for x. If we thought about f lambda x lambda y, what we got lambda x plus lambda y over lambda x. So lambda will be cancelling out. Again we got this fxy. So this is a homogeneous. If we think about this equation here, if we further simplify it, we can get 1 plus y over x. So here you got y over x. If it is a homogeneous equation, what you find is even if you more simplify it, you will get this y over x terms. That means all the equation can be written as y over x terms. Y over x squared, or maybe in other problem it is y over x squared. So in this homogeneous type, first order homogeneous type, this is the method. The equation can be written from y over x terms. It is the same meaning as this f lambda x is equal lambda x lambda y is equal xy. So let's get started on how to solve these homogeneous equations. How to solve these homogeneous equations? It is really easy actually. The thing we have to do is we have to use a substitution. The substitution is, you have to remember it, y is equal vx, or you can also use x equal vy. In some problems, either if you use either of these, it will be okay. But some problems, it will be really easy to use one of these if you think about it. So this is the substitution you can use. Here v is another variable. Okay, it is not a constant. So you have to change the let's do a problem here. Let's say dy over dx is given as x. Let's take our first question. Our first question is 2y to the power 4 plus x to the power 4 over xy cube. So first you have to identify this as a homogeneous equation. So the very easy way to you can do it is the highest power in the numerator is you can guess the 4 from x and y. Even in the denominator it's 4. You can say it's 1 here. So when you take in this highest power, if two terms are multiplied, you have to take the sum of the these powers. Okay, this 1 3, so altogether 4. So if there is an addition, you don't need to do anything. You just have to get the this 4 here. So by that method, you can easily find out homogeneous equations. So now what you have to do is get the substitution y is equal v x. So if you use the substitution y equal v x, you have to find dy over dx here. So you have to derivate this equation here from x. So dy over dx is equal, this is a multiplication, so we first multiply, so we first derivate v and just write x. So it's dv over dx times x plus v times 1. So if we write y dash is equal v dash x plus v. So for the y dash term here, we have replaced it as v dash x plus v plus y dash. We have to replace it because we are going to do a substitution. Don't forget to change this dy over dx. So now v dash over x plus v 2 times y means v4 x4. We don't going to change x. X is exactly there. We want only x. So y is v cube x cube. So as you can see, all the x term here is cancelling out. So it is v dash x plus v is equal to the power v4 plus 1 over v3. So again, if you look at this, dv over dx times x is equal to 2v4 plus 1 over v3. If you put this v to this side, becomes minus v. So it's like minus v4, which is just equal to the v to the power 4 plus 1 over v3. Now what you can see, this is variable separable method. Again, in these differential equations, if you go further complex differential equations, what we most of the time doing is we simplify it uh, to a case that we already solved. So this is variable separable method. So what this I have to do is put v variables together here. v3 v4 plus 1 v is equal 1 over x dx. Now integrate both sides. So this is really easy because in the previous video I tell that the differentiation of the denominator. What's the differentiation of v4 plus 1? It's like 4 3. It's like 4v3. So we had 1 over 4 and 4 here. So no problem. So the differentiation of this term is on the numerator. So we can straight away write as v4 plus 1 is equal to, this is straight away ln x this is of the same idea. The differentiation of x is 1, it is on the numerator, plus c. So again, let this v is something we put, so we have to get rid of it. So v equals y of x. So v is equal y of x, and y of x to the power 4 plus 1 is equal to ln x plus c. So we are done. So that is how we solve this homogeneous equation. So the first, if I write the steps, first we have to identify this as an homogeneous equation. For that, we can simply just look at the highest powers of the numerator and the denominator. When we're looking at the highest powers, if there is a multiplication, we can get the sum as the highest power. So here this is 4 and 4, they are same, so this is homogeneous. So we use substitution after identify as homogeneous equation. After putting substitution, we have to, this is really important, we have to change the derivative, because dy of dx, the y is not exist in the next steps here, because we use substitution to get rid of y now. So we have to get rid of dy over dx and then simplify it. Then we have variable separable method and solve the differential equation. The next step, solve the differential equation. This is like 1, 2, this is like 3, and this is like put the substitution 4 and solve the differential equation like 5. And after solve the differential equation, you have to again pull back the y. So it's the sixth step. So only six step you can solve any homogeneous differential equation. So I'm going to do the next question with you. The next question, the second one, it is dy over dx is equal to 2xy over x squared minus y squared. So in the upper side, the highest power is 2, the lower side it is also 2. So since they are equal, we find this is a homogeneous, first order homogeneous equation. So substitution is y is equal to x, and we have to differentiate this from x. So y dash equal v dash x plus v x dash means x. Remember, we differentiate by x, differentiate by x, differentiate from x, from x. Since this is a multiplication, you know how to do it. And next, we replacing our substitution. X is there, so y is replaced by vx. So x is there, y is replaced by x. So all the x terms are cancelling out. Now it is 2v over 1 minus v squared. V dash x is equal 1 minus v squared. If we put this v onto the right side, it becomes minus v. So it is minus v plus v cube. So altogether it's v cube plus v over 1 minus v squared. Again guys, look at my steps, okay? If there is something I forget, please tell me in the comments. So yeah, now what we have to do is, this is variable separable. v over dx is equal v cube plus v over 1 minus v squared. Again, this can be simplified, isn't it? If we get v out of this is v squared plus 1 over 1 minus v squared. I guess not. I guess not. I guess this is the most we got. So I put the v variables all the way to the left side. So it is 1 minus v squared over v times v squared plus 1 dv is equal to 1 over x dx. So now we have to solve this. So we can use partial fractions on the left side, I guess. On the right side is okay to differentiate it. So we have to differentiate the other sides. The right side is okay. So guys, so let's do partial fractions here. So I will do it in the left side. So we have to 1 over v squared v times v squared plus 1, that will be equal to sum cost of v plus dv plus c over v squared plus 1. So I guess you know how to do partial fractions. When we are doing partial fractions, the main rule is uh, these two terms should be written as uh, sum, and this numerator, the power of the numerator should be 1 less than the power of the denominator. We know that in the denominator here we have v to the power 1. So if we subtract 1 here, it is v to the power 0. That means it is a const. So it is a const. Here we have v squared plus 1. So highest power is 2. So since higher power is 2, so numerator should be like b v plus c. So it is should be a polynomial with v to the power 1 highest power. That means degree. Degree means in the context of algebra, the polynomial in the polynomial degree means the highest power. Okay, in differential equations we say degree as the highest power of the uh, highest derivative. Okay, so in this context this is just some polynomial, some algebraic polynomial. So it should be a polynomial degree with less than this 2 here. So if we simplify it, 1 minus v squared should be equal to a times v squared plus b times v squared plus a plus cv plus a. So if we consider v squared terms on the left side, the minus 1, but in the right side there is a plus b. If we consider v to the power 1 power, in left side there is no, so there is c here. So c is equal to 0. If we consider constant, the left side there is 1, the right side there is a. So a is equal to 1. Since a is equal to 1, what is that imply? B is equal to minus 2. So this can be written as 1 over v plus minus 2v over v squared plus 1. If we integrate this, it is ln x plus c dash or c. Okay, so if since this is a integration, we can separately integrate these two. So it is ln v minus the differentiation of the denominator is on the numerator. So we can simply write ln v square plus 1. ln v square plus 1 is equal to ln x plus c dash. I written the c dash because on the left side in this integration there is also constant. So the constant change here. Okay. So right, we're done. So we can further simplify it. ln v over v squared plus 1. We can use some rules of logarithms. Uh, it can be like written like this. equal ln x plus c dash. So now we just have to replace v. So v is equal to y of x. So v is equal to y of x. So here y of x square plus 1. I'm not going to further simplify. So this is the solution. So this is the solution. So if you follow those steps, it is really easy. So the next question, the third one, dy over dx is equal to y plus square root of x squared minus y squared over x. Here, by looking at this, you can say this is homogeneous equation. In the denominator, the highest power is 1. In the numerator also, the highest power is 1 because there is x squared, y squared, but there is a square root. Okay. Since there is a square root, we should get the highest power as 1. Okay, because there is a square root over there. We know that mathematically we cannot write that, because since there is a square root and there is a minus mark here, we cannot differently use the square root here. But 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 from the sense that since there is a square root, since there is a square, we can think it as x to the power 1. So since there is y also to the power 1, so we can think that the degree of the numerator also has a 1. So since these are equal, we can say that this is a homogeneous equation. So when you solve more and more problems, you will easily you can identify what are homogeneous and what are non-homogeneous equation. Remember, this is first order homogeneous type. So after that, we have to do substitution. V is equal y is equal vx. So y dash equal v dash x plus v. What we done is we differentiate our substitution by x, because we have here dy over dx. So we replace this by v dash x plus v, and y with vx plus square root x squared is there, v squared x squared over x. So you can see all the x terms are cancelling out. So that is v plus square root of 1 minus v square. So this v is cancelling out. So this is nothing now, just a variable separable equation. So this is 1 over square root of 1 minus v square dv is equal to 1 over x dx. We just have to integrate both of sides. So what is the integration of this part over here? So to solve differential equation, you should have some good practice of doing integrations. So square root of 1 minus squared means, if you remember, this is sine inverse v. If you remember, what is the differentiation of sine x? Sine inverse x. It is 1 over square root of 1 minus x squared. So if you use v, it's 1 minus square root of x squared. So if this is the differentiation of this, this is integration of 1 over 1 minus v squared over this. So if there's a minus sign here, it will be cos. So this is equal to ln x plus c. So sine is inverse v is equal y over x equal ln x plus c. So we are done. So I hope you can understand it, and I will let you to do the final question. And there is some interesting another theory hiding here. That is, if our equation is dy over dx is equal ax plus by plus c over, let's say, capital X plus capital By plus capital C. So you can see that this is not directly a homogeneous equation. This is not a homogeneous equation. But we can deduce, we can solve, we can simplify this equation to as a homogeneous equation. So we call this method uh, as reduction to homogeneous equation. Reduction to homogeneous. Homogeneous. Okay, this is a reduction to homogeneous. How it can be done? It can be done as this. We have two substitutions. For x, we do a substitution called x plus h. Y is equal to y plus, let's say, k. So this x here is another new variable kind of that's depend on x. This h is the constant. So h and k are constant. So if we do this substitution, what we got? Dy of dx is equal a times x. A times x means capital X plus h plus b times y means capital Y plus k plus c over capital A x means x plus h, y means y plus k. Here we have capital C. So if we simplify to what we get is ax plus by plus. If there is noise, guys, again please ignore, there is some kind of rain out here. So now what we have is ah plus bk plus simple c. In the denominator we have ax plus capital B capital Y plus dh plus, sorry, ah plus bk plus c. So we can choose, we have the freedom to choose this y and k. So we are choosing this y, h and k such that this term in here is equal to 0 and this term down here is equal to 0. So by solving this h plus bk plus c is equal to 0 and capital H plus capital BK plus capital C is equal to 0, we can find h and k value. H and k value. There is two equation, two unknowns, because simple A, simple B, capital A, capital B, and C are given. They are given in the equation. No? Here we are given those values. No? So this h and k are the unknowns. So we have two equations, two unknowns. We have to solve this equation and find h and k. So if we find such h and k, this term here is equal to 0, this term here is equal to 0. So now we look at the equation. Now what we have is dy over dx. We have to change dy over dx too, because we have now x is equal to x plus h, y is equal to capital Y plus k. If you think what, now if you differentiate this y down here from x, what we get? Dy over dx equal to d capital Y over d x. I think I show it down here. So we have the substitution x is equal to x plus h and y is equal y plus k. So if we differentiate this equation of x, dy over dx is equal to d capital Y over d simple x. If you differentiate this equation from y, dx over dy is equal to capital X over dy. So now I'm not going to remember I'm not going to do a proof, but I cannot tell directly. So here dy, the since this is a single variable, we can write this dy over dx as 1 over dx over dy. Only if single variable calculus, okay? Single variable calculus. You know, we are talking about ordinary differential equation, so only single independent variable. The y is a dependent variable. So this is correct in the domain of single variable. So it is equal to dy over dx. So dx over dy is equal to what? D capital X over d simple y. So you get this is equal to d capital Y over simple X. So here this term can be replaced by this is equal to d capital X over dy, and you upside down it, you got dy over d capital X is equal to dy over dx. So if we go all the way to here, we have dy over dx is equal to d. This term can be replaced by this term. So it is dy over d capital X. So here what I want to say is this dy over dx is kind of operate, okay? Since this is single variable calculus, sometimes you cannot like think as dy divided by dx. That is a wrong concept. So I just some kind of show you that this without like dividing concept, dy over dx is equal to dy over d capital X. By we can do some simple thing as this and show this dy over dx is equal to d capital Y over dx, same as we do here. So it happened because of this h is a constant. H is a constant. So now we can replace this dy over dx as d capital Y over d capital X, and that is equal to a capital X plus b capital Y over c capital A capital X plus capital B capital Y. All other terms becomes 0. These terms we intentionally make it to 0. So now we know how to solve this equation, and after solving this equation we have to remove these capital X and capital Y. To that we need actually h and k values. So that is why we want to find those values. Yeah. So if I tell you the steps here, first step you have to identify this as this can be used by reduction to homogeneous differential equation, and you do the substitutions here, and after substitution, most important, you have to change the dy over dx, and also with the substitution you have to change the variables in our equation and make these two equal to 0 and find h and k. That is the fourth step. And after that you have a nice homogeneous equation, solve it as we talk about, and then again remove capital X and capital Y with simple X and simple Y and get the real solution. So let's do the first question in that part. So this is the first question we have in the paper. So our substitution is y is equal capital Y plus h, and x is equal capital X plus k. So if you remember, what we done is dy over dx can be replaced by d capital Y over dx, and when you do the substitution, what we have is y minus x plus 1 plus h minus k over y plus x plus, here we have minus 5 and plus h and plus k. You wonder how I write this. You do the substitution. I do it from mind. Maybe you have write another step to get in here. If you can directly do it, will be good. Okay. So what we're going to do is make these things to 0. So using a calculator, this is just kind of a simultaneous equation you can solve. So after solving it, what we get? So if you solve this, you will get h as 2 and k as 3. So since they are equal to 0, what we now have is dy over dx is equal to y minus x over y plus x. Now we have homogeneous equation, first order homogeneous equation. What is next we are going to do is doing some substitution. Y is equal to vx. So y dash is equal to v dash x plus v. So v dash x plus v is equal to, I replace y with vx minus x over vx plus x. So all the x's are cancelling out. We have v minus 1, v plus 1. So dv over dx is equal to v minus 1 over v plus 1. If I put this v into the right side, it will become minus v. So it is like minus v squared minus v. V is cancelling out, so it is minus v squared plus 1 over v plus 1. So now it is variable separable. V plus 1 over v squared plus 1 dv, that is equal to x in here 1 over x dx. So we have to integrate both sides. So here it is, we can rewrite this as, how we can write this? We can write this as v over v squared plus 1 plus 1 over v squared plus 1 v, and this is equal to ln x plus c. So if you integrate this, now we can integrate separately. Here 1 over 2 here and 2 here. The differentiation of the denominator is on the numerator. So we can simply write this as 1 half ln v squared plus 1. This is tan inverse integration of 1 over v squared plus 1, which is tan inverse v, is equal to ln x plus c dash. So if we remove v, we get minus half ln v is capital Y over capital X squared plus 1 plus tan inverse capital Y over capital X is equal to, here we have capital X, ln capital X plus c dash. We are not yet finished because x and y are not in the equation. X and y are things that we put. So we have to replace this capital X and capital Y with this substitution. So it is just simple y minus x. So minus half, and then capital Y is simple y minus h. H is 2 over x means simple x minus k. K is 3. K is 3 squared plus 1 plus tan inverse is y minus 2 over x minus 3 equal ln x minus 3 plus c dash. So we solve completely the solution. So you can see what we have done. First we identify this as reduction to homogeneous, then we do the substitution to reduction it to this here, and we find it k. We put this h and k such that this term goes to 0. So it can be reduction to really good homogeneous type. So then we put our normal substitution v equal yx and write like this, and we reduction it more to the variable separable method. Now we integrate it and we remove the variables that we put to solve this equation. So I'm not going to do the second one. So I welcome you to the B and C part. So I will do the D part. So we can rewrite this as dy over dx is equal to the dy over dx is equal to the x plus 2y minus 4 over 2x minus 4y. Now what is our substitution? Y is equal to capital Y plus h. X is equal to capital X plus k. So d capital Y over d capital X is equal to x plus 2y plus, there is minus 4 here, we have h plus 2, sorry, k plus 2h, k plus 2h. Down here we have 2x minus 4y plus, there is 2k plus, sorry, minus 4h down here. We make these two 0. So h is equal to, if you use a calculator and solve, h is equal to, let me put it in the calculator. So h is equal to 1 and k is equal to 2. So now we do a normal substitution. Y is equal to v x. So y dash is equal to v dash x plus v. So v dash x plus v is equal to x plus 2y means vx over 2x minus 4y means vx. So 1 plus 2v over 2 minus 4v. So dv over dx times x is equal to 1 minus 2v equal to 2v. 1 plus 2v over here, we have minus v here. So if you put the common denominator, minus, we have minus 2v plus 4v squared, and we have 4v squared plus 1 over 2 times 1 minus 2v. So that's a constant here, 1 minus 2v over 4v squared plus 1 dv is equal to 1 over x dx. So we have to integrate the both sides. Now let's look at the integration of our left side. It is just fine, okay? It is just fine, it is easy. We can just do 1 over 2v squared plus 1. I leave 4v squared as 2v altogether squared minus, here I have 2v over 4v squared plus 1. Leave it. Sorry. Sorry about the noise. There is a festival going on here. And yeah. Now you see here the differentiation of the denominator is what? It is like 8v. So if we put 1 over 4 here, we can make it to 8. So I didn't do anything, it is same as it was. So now if you consider this term here, the differentiation of the denominator is on the numerator. So we can use LA. If you consider this here, this is tan inverse 2v over 2v. Okay, if you differentiate this, what is tan? If you differentiate tan inverse 2v, you get 1 over 1 plus 2v squared. Okay, 2v squared. Since you differentiate from 2v times 2, so this is should be 2. So you have to divide from 2. So what you get if you differentiate this is tan inverse 2v over 2 minus 1 over 4. This is ln 4v squared plus 1. This is always positive, no wonder. Okay, 4v squared plus 1 is equal to ln x plus c dash. So again you have to do the reverse because v is something we put. So this is tan inverse to v means y over x minus 1 over 2. I will multiply this. So 1 over 2 ln 4v means y over x squared plus 1 is equal ln x plus c dash. So again you have to remove this capital Y and capital X. Tan inverse 2 y means simple y minus h means 1, I guess h is 1. X means simple x minus k is 2. So 1 over 2 ln 4 y means y minus 1 over x means x minus 2 squared plus 1 is equal to ln x minus 2 plus c dash. So this is the final solution to our solution. So I hope you understand the steps. Right? So if I do any if I did any wrong thing or wrong step here, let me know, and if you have some doubt, let me know. So thanks for watching. We we will meet in a future video. Actually next video is about, I guess, some kind of another method of solving differential equations. So thanks for watching. Bye.